My name is Victor Feng, Senior System Security Analyst in SEI. Today, I'm happy to be here and share with you our Graylog experience. And I'll do my best to show you the experience or the things we learned from our failures, and show you all that so that you will not go through those. And hopefully this presentation will be helpful for you. All right, so let's get started. So today's topic is overcoming the performance issue for your Graylog. So we'll just dig into it. So today's agenda is 3 parts: Graylog cluster performance, OpenSearch cluster performance. Last piece is license traffic limit violation. So first part is Graylog cluster performance. We'll spend a good amount of time here. So a little bit of introduction for our SCI Graylog. We started Graylog in year 2016. Our old SIM was so old back then, and it can take 15 minutes to run a little bit small query. So that was the main reason we started to build a Graylog. After we have a Graylog up and running, same search now only takes 3 seconds. In early year 2017, our Graylog ingestion rate was 5,000 logs per second with 8 Elasticsearch data nodes. So back then, it is an Elasticsearch node. OpenSearch was introduced 2 years ago. 3 master nodes, 4 Graylog nodes, 3 Mongo database nodes. We had 60 terabyte storage. Today, our injection rate is 20,000 logs per second with 12 OpenSearch data nodes, 6 Graylog nodes, and 120 terabyte storage, which holds about 6 days online data. And each data node's table is CPU to 24 CPUs, and the memory stays the same, which is 64 gigabyte. And the Graylog nodes got 4 times resources they had before. Memory increased from 8 gigabyte to 46 gigabyte. CPU number increased from 8 CPUs to 32 CPUs. Currently, we're running Graylog 5, and we plan to upgrade that to 6 in early next year. So let's start with Graylog node memory. Since the conference does not encourage the presenters expose clients' confidential information, we do not want to expose that anyway. So information such as host name here will be back out during this presentation. When Graylog journal queue gets piled up, like here. And a quick way to determine if it is because Graylog node does not have enough memory is to check the JVM usage. So if the JVM usage is kind of 90%, if it's more than 90%, and then we can say pretty much the problem is memory shortage. In example here, the JVM is using 962 megabyte out of a total 100 gigabyte. So we're pretty much know the problem is because the Graylog does not have enough heap memory. So now let's increase the memory to 4 GB. And we're going to add the memory to the VM first, and then start from VM. We assign 4 GB to the Graylog, and then we'll see what happens. All right, after we added the memory, we're going to restart our Graylog server service. From there, you will see surely the journal queue will go down, and as we showed in the screen, this one go down 58,000 unprocessed messages, and the memory usage is about 50%. So that's well below 90%. Now, where's the problem? When we have a journal piled up, we're gonna try to get a basic ideas of where the problem could be. Is it from the Graylog, or is it from the open search? So we know the Graylog also have the MongoDB. Most time it's not from MongoDB. It's going to be either OpenSearch or from the Graylog. Another thing is, no one likes to sit in the Graylog and to stare on the Graylog to see if there's any journal queue piled up. So you wanted to have some alerts to set up to alert you when the Graylog queue is piled up. So in our place, we have a nodules. Nodules send our alerts to us when the journal queue piles up. So I'll show you the nodules a little bit later in our next slides. Now, so if we have so the way we're going to look at things is look at the buffers. In Graylog, there's 3 buffers. So one is input buffer, another one is a process buffer, another one is output buffer. Normally, input buffer is going to be all fine. The problems are the process buffer and output buffer. When output buffer is full, which is 100% here, and output buffer is not full, and then we know the problem is in Graylog nodes. On the other hand, if the output buffer is full and the process buffer is not full, and then we know the problem is from OpenSearch. All right. So depends on your situation. You may look at the problem a little further. For me, after a few checks, I would normally just have a quick reboot to solve the problem. And remember, when you reboot the Graylog nodes, the messages in the buffer could be lost. The message buffer here, we have 65,000 in the process buffer. But for me, it's still something I have to do, especially when woke up in the middle of the night by nodules. I would like to do a quick turnaround and I go back to sleep, right? So I do a quick reboot. Also, many times, you do not have enough time to investigate the problem anyway. Before the journal starts to overflow, the logs lost through the overflow will be much more than the loss in the buffer. So many times, reboot is a win. Now, let's take a look at the nodules monitoring script. So basically, it's a bash shell. So in this bash shell, the threshold we set is 5,120. That's megabyte. So that's that's exactly 5 gigabyte. The Graylog journal, we set that to app Graylog journal. So that's my Graylog journal says. When the journal usage is more than 5 gigabyte, and then we change the variable results from 0 to 1. And then the last few lines is the standard output. It's standard lines for Nigel's. That's what Nigel's needs. Well, Nigel sees critical, which is number 2, and then Nigel's needs, that's something that you need to alert to. And when the exit is okay, which is 0, and then Nigel's is all good. Now, in your place, if you don't have a Nigel's, you can modify the last piece. Here, you can say you're going to be sending you an email to you, and you run that as a cron job, if that works for you. Now, let's look at a scenario. The problem could be computing shortage. So we see here the journal queue is piled up, and the JVM usage is low. It's reasonable. Now, what do? We just have to look a little bit further. So here we have our process buffer is full and the output buffer is not full. Actually, it's empty. Based on the principle we laid out in previous slides, the problem is in Graylog nodes. By checking around your server, if you notice the system load is high, if you see your system load is high, and then the problem is Graylog node is craving for CPUs. I ran into this situation before. After rebooting the Graylog nodes, the journal queue might be cleared out, but a few days later, the journal queue got piled up again. So I started to monitor server loads a little bit closer, and I noticed that the server load got higher than before. So I had our infrastructure team to add more CPUs to the VM. The node had 8 CPUs before, and they added 6 CPUs to it. So you would think things were getting better, right? But actually, it does not. The problem was still there, and our Graylog node still got a pile up. And in the middle of the night, Nigel sent us alerts, and we got up and rebooted the nodes. That was not fun. Until one day, my colleague Jim ran into these Graylog parameters. So basically, in Graylog, the default processors assigned to the process buffer is 5. So in my case, it doesn't matter how many more CPUs I added to the VM. So we just have to increase the process buffer. Today, our process buffer use 24 CPUs, and we increased our output buffer to 6, and input buffer, we didn't have any change. It's still 2. All right, so besides this obvious memory shortage and a CPU shortage of the Graylog nodes, let's look at the other technical reasons that could cause the journal pile up. First one is indexing problem. Basically, for some reason, a log could not be saved into an index in the backend, which is OpenSearch. Second problem is parsing problem. Basically, the parser is not able to parse a log. When a lot of logs could not get parsed, Graylog node could got piled up too. Third reason is the log can have a sudden jump on intense pipelines. Some pipelines have some rules which demand a high computing. When logs spike, Graylog may not have enough resources, such as CPUs, to handle the load. The last reason is the intense API calls from outside. You may have some applications need some data information from Graylog. They make API calls to your Graylog. Sometimes the API calls can get intense because Graylog is not able to process logs, and so the general queue get piled up. Now, let's look at the first reason, indexing problem. Index problem is the most common problem to cause general pile up in our shop. As highlighted, currently we have 170 indexing errors in the past 24 hours. This is the very minimum. In our old days, we could have 500,000 errors per day. For some bad days, after we started to pay attention to these indexing error, get them fixed, and our Graylog run much smoother. Generally, if you have a few thousand index errors per day, you're totally fine. It will not cause any problem. So let's take a look at the error here. Error says reason equal mapper event data parameter 15 cannot be changed from type keyword to date. Event data parameter 15, that's the name of the field. So in the keyword here, this is Graylog 5. In older version of Graylog 4, it will be show you says it's a string. So in old version is still a string, but in Graylog 5, it's going to be a keyword, but that's just a string. When Graylog starts a new index, the data type for each field in the new index is determined by the value of each field in the first log. For example, because the value of the event data parameter 15 in the first log is a string when the index when at 1611 is created, event data parameter 15 is set to type keyword. From there, if there's a log which has a non-string type value for field event data parameter 15, OpenSearch will throw an error back to Graylog. Say, hey, this log does not have a string type value for field event data parameter 15. Here, the error message says field event data parameter 15 has a date type value, and OpenSearch cannot change the keyword to date. Now, how to fix the error? So before we do that, I forgot to say this presentation is pre-recorded. So if you have some question in the middle, and you're welcome to type into the chat, and I'm in the back end and try my best to answer your question. All right, so let's carry on. So if you're running Graylog 6, and then Graylog 6 has a new feature, you can do this through the GUI. So you go to the index which has a problem. In this case, we assume is a default index, and you click on the configuration, and then click config index field types, and then it will give you a list of the fields in your index. And here I just pick the SM underscore device field, and then you will get the pop-up here, and then here and the drop down, you'll pick the new field you would like to change to, and then you pick the new field, and then check this box so that after you apply the changes, and the index will rotate, and if the changes will be effective in the new index. Now, for older version of Graylog, like us, we're Graylog 5. Actually, we're not really old. And we just have to go through the command line. So we're going to be run this command to make the API call to list all of the fields, the data type. Currently, the Graylog underscore 414. 414 is the latest current index. And this is your token, you need it. And then after you run, you just make sure the fields in question, for example, the event data parameter 15 is a string. And then from there, you need to, second step is we need to make a JSON file. So this default format. And then the things we need to put is the new type. Here, we change to date. All right. So here I throw into another scenario for index errors is sometimes you will see a field can have a value be too long, and OpenStreet cannot handle more than 32,766 the values. If it's that long, it will cause error. So you're going to be say, hey, go ahead, you can lower that. All right, so after we get the JSON file ready, and then we're going to run this command, and we're going to plug in this JSON file here, and we run this, and we will give you some feedback whether the change is a success or not. After it's a success, and then you will log into your Graylog GUI, and then rotate the index so that the change can be effective right away. All right, so our second problem here is parsing problem. So normally we write our parsing rules based on what logs we currently have in our streams, but many times we will have a different format of logs ingesting to our logs in the middle. Then the parsing rules in the pipelines are not able to parse them. That can cause journal pileup. What we can do is to click the more action here, click get process buffer dump. From there, you should be able to see what logs in a process buffer. Depends on how many CPUs you have. You will have corresponding number of the rows of data here. Many times, when all of these logs have the same format, it's most likely a parsing problem. When it is a parsing problem, and you can go back to the previous page and click on the nodes, click on more action, click on the get process buff dump like we did just in the last slide. You should get exactly the same logs because those logs just stuck in the process buffer. From there, you can take a copy of the logs for the next step for simulation. Now, when you see a piece of log, you should know your Graylog well enough to know what string this log belongs to and what pipeline the string connects to. For our firewall logs, we name the string as all firewall logs and name the corresponding pipeline as a firewall pipeline. When I see the logs in the process buffer, I know they're firewall logs. From there, we click the simulator. That brings us to the simulating page, and then select the corresponding stream. In this case, is all firewall logs, and then paste the logs we copied just a while ago into these raw message fields. All right, let's keep going. For the message codec, select syslog, and then click on the load message. Take a look at the simulation result. All right, let's take a look at that. In the added field section, if you do not see the fields you expected, for example, if I do not see the SM action type, etc., should have a bunch of the fields you would like to see, then this piece of logs is not parsed. So this is quite straightforward. So we will need to go back to the firewall pipeline. Here is stage 1, stage 0. That's where we start to parse our logs. And then you will just need to create a new rule to handle this new type of logs. All right. Third reason. Sometimes you can have the log spike in the pipeline where it already have intense demands for resources. For example, this pipeline rule leads to search through another stream to get firm ID. slookup is for string lookup. It is a third-party plugin. 5D9, etc., is the source string ID we need to search from. Here, in our example, is our firewall string. First field, SM source ID, is the field in the source string. And second field, SM source ID, is the field in kernel string in your pipeline. Number 5 is we search through the last 5 seconds in the source string. So basically, Graylog takes the value of SM source IP in the kernel string log. For example, you want to search 8.8.8.8. Graylog searches the firewall logs for last 5 seconds and returns the logs which have SM source IP equal 8.8.8.8. So basically it returns all the values of the field you need. In this case is SM firm. And the descent tells us we will take the newest matches because we only need one value. In this string lookup, how long past you need to search is the key to determine how intense the search could be. Of course, the longer you search back, the more intense the search would be. We had a few adjusts to make sure the search would not cause a performance problem. One time, our IDS service had an outage. After it was fixed, it started to send whatever logs it didn't send in the past few hours. Our Graylog just could not handle this spike. Finally, I just have to disable this rule temporarily and let the leftover logs come in first, and then re-enable the rule. The last reason is the intense API calls from outside applications. For our shop, we send Graylog loads to Firefly. Firefly is a homegrown application. And it is a ticket managing system. After receiving an alert, Firefly will make some API call back to Graylog to search for some data. Depending on how far back the search would be, sometimes the search could be too much for Graylog to handle and cause general queue pileup. I know our Firefly would make a lot of API calls from the very beginning, so I had a dedicated Graylog node for it. This node does not ingest any logs. One time, our Graylog had a serious problem. We constantly had a journal queue pileup. After I did all kinds of investigations, rebooted the Graylog and I searched many times. Problem was still there. I started to suspect this could be Firefly caused the problem. It took us for a while, especially it's just me, and it took me for a while to convince our programmer to adjust the API calls. From that on, I put a little bit of logs into these Graylog nodes. In future, whenever this log, whenever the general queue in this node got a pile up, I knew right away that the problem is from Firefly. All right, now let's circle back. What's the problem as we touched the topic earlier? Is it a problem in Graylog nodes or is it a problem in OpenSearch? As we said earlier. Now the general principle is if process buffer is 100% full and the output buffer is not full, then the problem is in Graylog nodes. If output buffer is full and the process buffer is not full, and then the problem is in OpenSearch cluster. Now, let's look at another scenario and kind of add on a little bit, getting a little more complex. So for the ones who have multiple Graylog nodes, when you have only one node piled up, if you have only one node piled up, the problem is likely in Graylog node. If you have a piled up on multiple nodes, the problem is most likely in OpenSearch cluster. if you have, like us, we have 6 nodes. And here if you see 2 or 3 or 4 nodes, they all pile up, and most likely the problem is OpenSearch cluster. So if you have time, you can do some deeper research. And but sometimes the problem can be a big search from your users, or because the system can have some glitch. So many times you may just have a quick reboot. So that's sometimes I would do. Now let's go to the second part, OpenSearch cluster performance. In SCI, we have data nodes is 64 gigabyte memory. 31 gigabyte of those is allocated to OpenSearch. For OpenSearch or Elasticsearch previously, the maximum heap memory you can give is 32 gigabyte. If you give more than that, it will not help with the performance. Actually, it will deteriorate the performance. Each data node has 24 CPUs, each for us, and each node has 300 shards. Each shard has less than 30 gigabyte. So I basically follow the rules set by Elasticsearch previously. For the storage, we use enterprise disk, and they're all flash drives. For the index settings, we set the index shards to 6 and the index replicas to 1, because we have 12 data nodes. So our data is spread out evenly to each node. Each node gets 1 shard for each index. So each of our data nodes space usage is pretty much the same. By the way, do not check this box. Disable index optimization after rotation. Optimizing index will save us a lot of space. Let's continue with index settings. We use index message count as our index rotation strategy. As for the max document per index, I kind of observe to see how many logs we need to reach 100 gigabyte. 100 divided by 6, that's 30 gigabyte. So for this index, it is about 20 and 70 messages. We keep 95 index, which is worth about 6 days worth of data, and then delete the oldest index after index rotation. Our index archiving does not take place here. Waiting for 6 days, and then archiving is a little too long for us. We have our QA environment, and we do index archiving there. For data node, the most important metrics is disk performance. Let's take a look at the output of the SAR. The depth, SDA, SDB, SDA is our OS disk, SDB is our application. Starting from SDC, SDD, etc. There for OpenSearch indexes. There, as I said, is a flash drives. Let's take out the await metrics. Based on source manual, await is the average time in milliseconds for I/O requests issued to devices to be served. This includes time spent by the request in queue and the time spent in serving them. So basically, the value of the wait tells us how fast our OpenSearch does the read and write. Here, during normal hours, the wait for SDC is 2.3 milliseconds for I/O. It's about 2 milliseconds across all of our disks. So 2 milliseconds is pretty good, actually. If you do not have a flash drive, you may get 20 milliseconds. Now, let's run a big query here. And we search the username, start with username for the last 60 days. And then a wait time increased to 7 milliseconds. So that's still pretty good. All right. Finally, I come to license traffic limit violation. For the shops where you have a separate index for certain logs, we need to make sure our logs are not stored twice. Otherwise, we're double paying them. For example, we have created a firewall index, and for the all firewall string. So here you want to make sure to check the box, remove matches from default string, so that the firewall logs will not be stored in the default index a second time. Another place to cause the logs duplication is the pipeline when you route the logs to another string. So here we need to route our firewall logs to the string cyber intel indicator. So for string cyber intel indicator, just make sure you set the index set to firewall index, and the box also make sure you check this box. All right, that brings to the end of this presentation. Hope it is helpful for you. Thank you.